and only use the interactions as excluded instruments. So now we run a regression where we have as the exogenous variables both the group indicators as well as the QI, the original basic instrument. As the excluded instruments, we have the remaining interactions. Then we do the modified version of the bias two-stage least squares. And as long as the correlation between the gammas and the pi's is equal to 0, this is still going to give us a consistent estimator. Let me then finish up by looking at what this does in the Angus Krueger data set. So here we take a subset of this data with people born in the first and fourth quarter, and we look at 3 sets of instruments. Single binary instrument with a single exogenous variable. Then we do something closer to, not quite the same as what Angus Krueger did. We interact the quarter of birth dummy with state of year times year of birth, generating about 500 instruments and about 500 exogenous variables. And finally, we only use the interactions as excluded instruments and incorporate the basic quarter of birth dummy as an exogenous variable. So explicitly allowing now for a direct effect of quarter of birth, partly addressing the concern that there may be seasonality in quarter of birth associated with socioeconomic status. And so we find here, so in this table, with the first panel corresponding to estimators using just a single quarter of birth dummy, there all these estimators are the same, all the standard errors look the same. Then we look at a case with 500 instruments. The estimators still look very similar, but if we allow for if we take account of the many instruments, the standard errors get considerably larger. They're allowing, in addition, they're taking into account in addition the fact that as many exogenous variables doesn't change the instruments very much, allowing for the possibility there that lambda 1,1 is positive, doesn't change the standard errors very much for the bias corrected or the jive estimators. That cannot be done for Limmel because Limmel is not consistent in that setting. And finally, if we allow for a direct effect of quarter of birth, it turns out that taking account of the many instruments in that case shows that there's not enough precision in the data to estimate things precisely enough. But so what the data suggests here is that there's actually very little evidence that the instruments are invalid, and we can allow for the possibility that there are direct effects of the instrument, as long as the product of those direct effects and the direct effects on the endogenous variable averages out to 0. And so the recommendation really is to, in cases where there's concern about the validity of the instruments, to focus on the bias-corrected two-stage least squares estimator, keeping in mind that Limmel is extremely sensitive to any violations of the exclusion restrictions. All right, let me finish. Yep.
Well, Hito, I knew that quarter birth was a valid instrument, so I'm glad to see that you're convinced as well. But you know, the problem I see with this line as a kind of an applied guy is, how do I convince somebody that product term, that the gammas and the pi's are unrelated? How would I go about marshaling evidence for that?
Well, I think my main conclusion from this is, so prior to some of this work, what I would have recommended to people doing this in practice is just always do Limmel. Limmel deals with the many instrument problem very effectively, and it's still efficient, and it's easy enough to calculate. Now, understanding that LIML gets to its efficiency properties by really enforcing the proportionality of all the reduced form coefficients, I would modify that a bit. I would be inclined to routinely use the bias-corrected two-stage least squares estimator, because that has essentially the same properties as LIML when the instruments are valid, but buys you some robustness that I think in a lot of applications is meaningful. I don't see it as much as requiring that the product of some large set of instruments, the coefficient of some set of instruments, and on the endogenous variable and the outcome is equal to 0. I see it more as that the direct effects of the instrument need to be uncorrelated with the direct effects in the first stage. And I think in some cases that is considerably more plausible than requiring all of those direct effects to be equal to 0. You can sort of interpret this somewhat like clustering, where there's different things floating around, there's sort of different institutions in the different groups, and so in particular in settings where these instruments were generated by having some basic instrument interacted with a lot of group indicators, I think this is going to buy you some meaningful robustness.
Oh, so how many instruments are many instruments? Because one doesn't work with two, even if you have that condition. 1 and 2 being equal to 0, does it work?
I think in practice, you should just always use the estimator associated here with the many exogenous variable setting. The change relative to the two-stage least squares is very small if k and n are relatively small, and it just increases with the number of instruments. But so if in fact you look at the properties of these estimators under the fixed number of instrument asymptotics, under the conventional asymptotics, they have exactly the same properties as LIML and two-stage least squares. So you're not really losing anything. So at least in large samples, you're not losing anything by using these standard errors and by using these estimators. So it's more that I don't see any reason for using the estimators that don't take these things into account. Thank you.
Okay, good morning. I want to thank the organizers and Andrea and Eduardo in particular for the invitation and the opportunity to visit your beautiful country, though I know it mostly from pictures. Hopefully I'll have some chance to see it in reality. This is a joint work with Rana Avramitsky from Stanford, and there are two motivations for this paper. The first one is from a labor economics, human capital point of view. Two seminal models, Yoram Ben-Porat, 1967, Becker, 1967. The main motivation for individual to invest in schooling, in human capital formation, is the future earnings, and that's related to the rate of return to schooling. So the higher is the rate of return to schooling, the longer we would expect individuals to stay in school. So the problem is that it's very difficult in reality to observe individuals with different rates of return to schooling, and very rarely do we observe a sharp change in the return to schooling. So this premise, which is very fundamental in economic theory, labor economics in particular, was hardly tested in the past. Second motivation or perspective of this paper is with public economics. We're interested in the relationship between the rate of income tax and the labor supply, in particular the labor supply in the long run, to study that mechanism, we really want to know what happens when we change the tax rate in terms of schooling, because that has a direct effect on labor supply in the long term. Again, this is an important question with very little evidence. Again, for the same reason, hardly you observe variation across individuals in the return to schooling, and hardly do you observe over time a sharp change in the return to schooling or in the tax rate. So in this paper, we have the opportunity to address these two issues, which are important for these two streams of work, labor and public economics. So in this paper, we address this question by using a very particular episode where we observe a very sharp change in the tax rate, a reduction from 100% to something between 30 and 40%, and an increase, a respective increase in the rate of return to schooling from about 0 to about 8%, which is the national average rates of return to schooling in Israel. And we use this natural experiment to address, using differences in differences methodology, the effect on teenagers' investment in human capital. So teenagers are exposed to this change, these two types of treatments. First is the reduction in the increase in the tax rate, the reduction in the tax rate. Embedded in it is a high increase in the rate of return to schooling, and we are using this episode to see how teenagers aged 16 to 18 respond to this information, this shocking information, to their investment in schooling and their outcomes. So as you'll see, our context is Kibbutzim in Israel, and I'll explain in a minute what is Kibbutzim for those who are not familiar. The framework is diffs and diffs. This is in a nutshell the research approach. You observe here pre-reform cohorts, teenagers who graduated high school before the reform was implemented. We have the reform implemented in some kibbutzim. We have the reform implemented later in another set of kibbutzim. So all the data observation will come from units that implemented this reform that I'll describe in a minute. Some individuals were too old to benefit from the reform or to be affected by it. Others were young enough at the moment of exposure to react to it. So we have differences between kibbutzim and differences across cohorts, and these two types of differences will allow us to identify the treatment of interest. So as I said, this is a difficult question to address, and there is very little of evidence about the response of education to a change in the tax rate. There's also very little evidence to say something about the response of investment in education to changes in the rates of return. So most of the evidence is of correlational nature, time series analysis. I don't think we can rely on any careful, causally analyzed data in this perspective. So let me describe to you briefly the reform in the kibbutzim in Israel. Kibbutzim are communities in Israel that were created at the beginning of the previous century by pioneers who came from Eastern Europe to Israel and wanted to live in a commune, a cooperative commune. They were very strong ideologists, and they decided to live together and share all the product of their efforts, labor market efforts, equally dividing the fruit of their collective activities between them. So wages were exactly the same regardless of the contribution of each individual to the community. They were sharing everything, including the fruits of their labor force activities, namely income or production. In the beginning, they were mainly farming activities. Later on, they adopted also modification in terms of the composition of their activities, investing in manufacturing production, later on also in research and development, more high-tech activities. Over the years, about 350 kibbutzim were formed in Israel. At the peak, there were about 2% of the population in the country. And starting in the beginning of the 1980s, when Israel had a hyperinflation problem, the kibbutzim got into financial distress, financial difficulties, and they were looking for ways to move out and solve their economic problems. The government bailed many of them out from their debts. But this process started a change in the ideology in the kibbutzim. And in the mid-1990s, it started a debate about liberalizing some of the ideological foundation of the kibbutzim. And the one that is the strongest for our purpose is the fact that income was equally shared by everybody. And in 1998, first round of kibbutzim, about 35 of them introduced differential pay. So they have moved from equal pay to a pay that was a function of productivity, in principle, a function of their years of schooling. Okay? And let me show you this graph where you can see that before the reform, income was equally shared. This is data from few kibbutzim that we collected ourselves. And after the reform, this is in terms of education. We have an increase in income as education is increasing. You can see that more clearly when we estimate a Minsurian equation with data from kibbutzim. And you see that post the reform, the return to schooling went up from 0 practically, which you see here. This is a 0 return to schooling, to about 8.3% return to schooling. This is a simple regression without IVing it. And that's more or less the average rate of return to schooling in the country. So it's amazing how within a year or two, when the kibbutzim adopted this reform, the rate of return to schooling jumped from the financial rewarding of activities from 0 to the national average. That's partly explained by the fact that many of the kibbutz members work outside the kibbutz in the private sector. 40% of members of the kibbutz work outside the kibbutz. They used to get a paycheck. Until the reform was implemented, the paycheck was given to the kibbutz, who deposited in its own bank account shared by everybody. After the reform, the check was kept by the individual, and he had to pay a tax rate to the kibbutz, who actually collectively pay tax rate to the government. The reforms had two types of kibbutzim. One that had a partial reform. Partial reform meaning the tax rate was about 60% to 70%, much higher than the marginal income tax rate in the country. And many kibbutzim had a full reform, when it was a full differential pay, and the tax paid to the kibbutz were more or less the tax they would have paid to the government if they had paid taxes directly. Okay? So we basically are exploiting this episode to look at the two questions that I highlighted. Now, why compare kibbutzim who reformed to kibbutzim who reformed later? Okay? That solves a lot of the selection problem that may arise if we will compare kibbutzim who reformed to those who decided not to reform. Because they are very, very different in terms of background, in terms of ideology, in terms of the financial difficulties that they have experienced over the 80s and the 90s. Those who reformed just 2-3 years later or 4 years later are a fantastic comparison group, because basically they went through the same selection process of deciding about the reform. It's just the timing is different. Why is the timing different? Because most kibbutzim wanted to reach an internal consensus about this change. Some kibbutzim reached the consensus earlier than others, and that's why we observed them reforming already in 1998, 1999, and 2000. Others, it took a bit longer to reach this consensus in the kibbutz, and you should realize that this is like an earthquake of a degree 8 or 9 for the kibbutz of making this change. So that's why many kibbutzim decided it's better to wait a year or two until a consensus will be reached than shake the kibbutz and destroy it internally by doing it just by a mere majority of 51%. And the decision to reform basically was by a vote in the kibbutz. So how salient was the reform? How would a teenager, age 16, 17, be aware of the fact that his father or mother used to pay 100% income tax and now they're paying only 40%? That they had 0 return on their education and now it's suddenly 8%. This was a major issue. As I mentioned earlier, it was highly debated in the kibbutz. There was a lot of opposition. The elder individuals in the kibbutz were against it because they were the one mostly affected by it or threatened to be affected by it. It was something discussed on every table in every household. So people were very well aware of this change. So Another concern is, in terms of identification strategy that we are using, is whether those who reformed later actually reacted to the reform because they observed what happened in those who reformed earlier. Okay? And that's something we cannot test, but in principle, that actually should reduce, bias downward, our effect, I mean, against finding something. So I think this is less of a concern. So the data that I'm using is data that come from the National Archive of the Ministry of Education. When we have the universe of secondary schools in the country, we have information about every student. It's administrative data. It's very rich in background characteristic. We have for every student all his outcomes during his high school career from 10th grade to 12th grade, including every matriculation exam he has taken over this period. Some of the exams are starting usually in 10th grade. The majority are in 12th grade. So we really have the universe of cognitive performance of students in high school. And we merge that with data sets from the Kibbutzim, from the system of the Kibbutzim, and we know exactly the date of reform of every kibbutz. We have many background characteristics about the kibbutz, including financial information about the kibbutz that we can actually use. Some of the kibbutzim implemented other reforms at the same time. For example, they have stopped eating collectively in the common dining room dinners, having only lunches in the kibbutz together, but stopped having it afterwards and basically privatized or into a catering company the food in the kibbutz. Others have done some other reforms. We are able to control for those so that any confounders to the main effect that we are studying, we can worry about that. So, as I said, the identification strategy is DID. We have many years of data before the reform, so we can actually do some placebo analysis or actually do triple diffs and diffs because we have many cohorts unaffected by the reform in earlier years. So the identification strategy relies on the assumption that any changes that have occurred in kibbutzim are unrelated to potential outcomes of the kibbutzim that reformed, so that we control for anything else that could confound the treatment effect. So we do few things well, before that, let me say that we have basically 74 kibbutzim who reformed early, 33 who reformed later. This is the number of students in the kibbutzim that reformed early. This is in the number of students that reformed later. And these are 10th graders in 1995, 1996, so that's pre-reform cohorts. So they have two cohorts before the reform. And these are the cohorts that we studied that were affected by the reform. So we combine this set of information for the differences in differences analysis. Okay, so we do a few things that I don't have time to go through to validate that. First of all, that at baseline, the kibbutzim that reformed early and late looks very similar in terms of background characteristics like parental education and outcomes. So the first difference basically in terms of outcomes is almost zero because the control and the treatment are very, very similar in terms of characteristic and in terms of outcome. Second of all, we look at differential trends, time trends in treatment and control using the before data, and again we find zero difference in the time trends in characteristics and in outcomes of the different cohorts that preceded the implementation of the program. Finally, we also look at exit rates. Kibbutzim is a free community. You can join and you can exit, and there was an exit rate which was higher in the early 1990s because of the financial distress in the 1980s, and we show again in the paper that the two types of kibbutzim, the treatment and the control, did not differ by the exit rates in any meaningful way before the reform started. So I will show you results mainly by what we call intensity of the reform. In principle, as I mentioned, there were two types of reform. Partial reform, where the tax rate went down from 100% to 70%, and a full reform when it went down from 100% to a lower rate, 40%. This has implication, of course, for the rate of return to schooling, which went up in the full reform to 8%, and in the partial reform went up only to 2-3%. Okay? So one way to do it is just disregard the nature of the reform, if there is any selection about the type of reform that the kibbutz implemented early, and just analyze the treatment effect by a 0-1 indicator, whether you reformed early or not, regardless of what type of reform you implemented. Those results are presented first in the paper, and we find significant effect on 4 different outcomes that we measure. I will skip that analysis. I will go directly to the intensity of treatment effect. We define 4 levels of intensity of treatment in terms of exposure of a student to a full reform. Some of the kibbutzim reformed from a partial reform to a full reform within the period of a high school, that kids were in high school. So within the 3 years the kids were in high school, his kibbutz might have started with a partial reform, and a year later moved it to a full reform, or 2 years moved to a full reform. So we define 4 measures of exposure to a full reform. 0 years, which means during your 3 years in high school, your kibbutz was under a partial reform throughout. 1 year of full reform, which means that your high school career was the first 2 years with a partial reform, the 3rd year with a full reform, and so on, until a full exposure of treatment to 3 full years of full reform. Okay? So let me show you the results in terms of the differences in differences. The first row is the effect of 3 years of partial reform, 0 years of full reform. The bottom line is 3 years of full reform, and in between, 1 year of full reform, 2 years of full reform. Okay? The outcomes that we study is whether you completed high school, even though the high school completion rate was already 93% before the reform, so we have a ceiling effect in a way that you cannot really perhaps observe much of improvement. We look at these results, whether the treatment improved school continuation, even in this highly achieving community in terms of completing high school. The second is the mean matriculation score. It's a test score. It's an average, the average score in a series of tests. Then whether you pass the matriculation rate, okay, the matriculation diploma, whether you observe the end of high school a baccalaureate, and whether your baccalaureate has the nature of allowing you to qualify for the university, which means that your matriculation program had to have 1 honor level subject at the highest level possible. Okay, so it's like a high placement courses. And you had to have English also at the highest level. Those are the 2 requirements university requires for admission beyond having a matriculation diploma. So we look at these 4 outcomes. Kids were exposed at the beginning of 10th grade to the program. We follow them for 3 years. We measure their outcomes at the end of 12th grade. So 3 years of exposure to different types of reforms. So let's contrast the partial reform to the full reform. Okay? So the partial reform improved the school continuation rate by, completing high school by 1.6%, but it's not precise. This is a standard error clustered at the kibbutz level. This estimates has a kibbutz fixed effect, control for a bunch of characteristics of the students, and some other dimensions of the kibbutz that were time varying. So the high school completion is improving, but it's not precise. The full reform, it's higher, almost 3%, a bit more precise, so you get something here that is marginally significant. Okay? The mean matriculation rate, the score went up by 1.2. When you were fully exposed to a rate of return to schooling from 0 to 8, your average score went by 5 points. I'll give you in a minute a sense of the effect size of these changes. Matriculation rate, 3.6% with a partial reform, 8.2%, and again, this is much more precise than the standard errors are the same, but the effect size is much larger. And the university matriculation rate up by 10%. Okay? So if students are forward-looking to continue schooling in post-high school education, you see that their university qualified matriculation is improved a bit more, although of course the 2 are not different. Okay? And if you observe the change over within a column, you see that there is somewhat monotonicity increasing from the lowest effect with the partial reform to the highest effect with the full reform. I have a few minutes, so let me tell you about the heterogeneity of treatment, which is very useful, both for understanding what's going on and where's the effect coming from, and also, in some sense, protecting us from selection bias, because you will see that there are a heterogeneity of treatment effect within families, and it's hard to think about a selection process about a kibbutz that might have affected other things, for example, school resources that would affect, for example, boys and not affect girls. They come from the same families. So you see here that the effect is largely on, no, I'm sorry, this is by low and high education families. So within the kibbutz, there are some people who have higher education, so the two groups are 12 years of schooling versus college education. This is the type of the population we have the kibbutz, almost no high school dropouts. And you see that almost all the effect come from the low education population in the kibbutz. Kids whom their parents did not have college education improved dramatically their outcomes in high school as affected by the program versus kids who come from educated families. So there is really nice heterogeneity in terms of who is affected. It's only those who come from low education families. And when we divide by male and female, all the effect, dramatically so, is on male and not on female. Male are the one who responds to the signal about the labor market returns to their attributes, to their education. Girls do not respond almost at all. You see that these effects are practically zero. Here we also present the partial and the full reform in each of the rows. And you see that the effect of the partial reform is zero for boys and girls. It's zero for high educated and low educated kids. I mean, the family is low educated and high educated. And the full reform has effect on kids from low education families and on boys. Okay? So very sharp heterogeneity. Let me put this magnitude in perspective by comparing it to several studies that have studied interventions that had the aim of affecting the same high school outcomes in Israel. So the first paper is a paper by Josh and myself on monetary incentive, when we incentivize high school students, and we found a 6% effect on the matriculation rate, but only on girls and not on boys, just the opposite of what we find in this paper. A paper on teacher bonuses that I've done, I found an effect of 3.3%. Okay? Remember, the effect I find is 10 percentage point increase in the matriculation, still at the moment higher than these two interventions. An effect on remedial education, providing remedial education to high school students, a paper by Anelia Schlosser and myself. We estimated an effect which was very close to the matriculation rate that we find here, something like 10, 12%. Okay? This one was the most expensive intervention out of the three. Okay? In terms of other evidence, for example, Progressa has an effect of 6.5% on enrollment of boys in 9th grade, cash transfers to families. The paper in Colombia by Angus and others, the school voucher program, find 5 to 7% effect on secondary school completion. And this is the paper which is close in nature to our paper, though it's an experiment. Jensen, 2010, in the Dominican Republic, had an experiment when he provided information to families and to kids about the return to schooling that they should expect later in their career, and that led to a 5 percentage point increase in enrollment in secondary schooling. So you see that our effects are very, very large. In terms of the cost of this reform, at least the direct cost, it's practically very low, if perhaps zero. And you see that individual responds very, very strongly to this incentive. What are the implications? Do we have any external validity to what we do in this analysis? We provide few examples where our evidence should be perhaps informative about other settings. One is the transition of centrally planned economies in Eastern Europe from centrally planned economies to open labor markets, where suddenly the rate of return to schooling increased. How would that affect the investment in schooling. There are some studies with data from the Soviet Union, from Russia or Moscow, but no evidence of this nature in those studies. Another interesting case is where some developing countries are liberalizing their international trade markets. That opens the labor market and increase the rate of return to schooling. You want to know how would individuals react to this liberalization of labor market as the rate of return to schooling is increasing. Perhaps a bit farther away in terms of external validity is our evidence could be useful in understanding the human capital gap between the first and the second generation of immigrants from developing countries to developed countries, where the kids are exposed now to returns of schooling which are much higher than their parents, and we observe the earnings of the children, the second generation, much higher than that of their parents. Stop here.
Yes, the returns to education were zero to the extent that kids of Kibbutzim members were expecting to remain in the, within the Kibbutzim. If that was not the case, then the returns to education would have not been zero to begin with, and the reform would not really have had such a large impact. It would depend on what your expectations are. So that's one point I wanted to make. And in terms of boys and girls comparison, it may be that girls and boys had different expectations of whether they would remain in the Kibbutzim where their parents decided to live. So,
yeah. But that's a good point. My reply to that would be that expectation about leaving the kibbutz should be different by treatment and control in order to make a difference for the interpretation of our results. And as I showed you, the rate of exiting the kibbutz, also by education of the people who exit, was the same before the reform for the treatment and the control. You still may argue that even though adults, who are those who exited the kibbutz, had the same exit rates in treatment and control, the kids in the kibbutz who are affected by the treatment may have different expectations about departing the kibbutz. That's a very unlikely situation, but that's a well-taken point which we discuss in the paper. In terms of girls and boys, again, when we analyze the exit rate, there is no gender difference in the exit rate from the kibbutz. Boys and girls, not boys, men and women are equally likely to exit the kibbutz when they are adults. Again, you may argue that as a teenager, girls may have a lower perception or probability about quitting the kibbutz. I would like to take the difference between men and women to a different direction. I think that perhaps at this age, girls are doing already maximizing more than boys than potential during high school, and we have evidence from other studies on that, so they perhaps need less of this extrinsic motivation for this. But I think the main thing is that girls are not expecting to be the main income earner in the family, and that's why perhaps their reaction to the reform is not as vigorous as we observe for boys.
You allocate all these effects to a change in the return to education, but there are other potential mechanisms, such as the fact that the teenage boy might not have been expected to might have been able to negotiate with his parents that now working on the kibbutz is a better solution, given that in the future he might be able to bring better returns. There are other alternatives I could think of, but what do you do in the paper to try to address those other potential channels? I don't know if the schools were in the kibbutz or outside of the kibbutz, and if the teachers' incentives changed through that. Those are a few ideas I had, but I'm sure you didn't have a time to go through all of those details, but if you could just elaborate a little bit on that.
That's excellent. Those are issues that we discuss in the paper. Other potential confounders, things that happen at the kibbutz during the same time. For example, school resources. For example, a change in the types of activities, the workload in the kibbutz. We check all of those things. For some of them, they are time varying, and we have measures. We control them, and we do some sensitivity analysis. I'm very confident about the results by the heterogeneous effect that we get, because again, it's within the family. It's the boy and the girl. Think about a family in the kibbutz who have 3-4 kids. That's the average number of children. They might have on average 2 boys and 2 girls. And within the family, we tried actually to do with a family fixed effect, because we do observe some families with mixed gender before and after. And we got some results, but they're really very noisy because the sample is much smaller. So I think the heterogeneity of the result is comforting beyond the things that we do in the paper in testing for the potential confounding effect of other time-varying changes. These are results that I think support the causal interpretation of our analysis.
So it's lunchtime. Remember that the next session starts at 1:30. Thank you.
Thank you.
Thank you very much.
Achievement for the children and income of the family. There's also been some examination of other factors such as characteristics of the mothers, their education, their other such characteristics. And they tend to show patterns of persistence of differentials as the children age, or increases in those differentials. And the kind of idea in the background from the point of view of more the biomedical or child development literature is that over the life cycle, if we have the life cycle representing the horizontal axis, there's different groups of children. The green line is an optimal group in which the protective factors, the good factors, strongly outweigh the negative risk factors from the time of birth on. The vertical axis represents various kinds of behavioral competencies, could be cognitive achievement, could be other kinds of competencies for this stereotypical picture. The red line, in contrast to the green line, reflects a path where the risk factors are rather large, and one has a gap, and perhaps an increasing gap over the life cycle, unless there's something that compensates, which the blue line illustrates the possibility of compensation of some sort of early child development programs or whatever, which may reduce the gap. So all this paper I'm doing, presenting is looking at these patterns, once again for cognitive achievement, but also for some other indicators. This summarizes some joint work in progress by the 3 panel members, by at least one other person in the audience here, Florencia Abu, maybe others in the audience, where we are looking at a series of countries in Latin America and looking at patterns like this. These figures are small, but in a nutshell, what they show, the red lines show the scores on the Peabody test, verbal test. The same test is being used in all countries for 5 different countries in rural areas, 4 different countries in urban areas. The red line are for the highest quartile. I guess it's blue line is for the bottom quartile. The point is these patterns show continuing gaps over this part of the life cycle in all cases, I think it's fair to say, probably increasing gaps in a few cases, such as rural Ecuador or rural Nicaragua. But of course, cognitive skills are but one kind of indicator of child development. And recently the economic literature, as you know, has put increasing emphasis on other dimensions of development, not just cognitive skills, such as executive function. So basically here, we're just looking at these patterns like this for the Chilean data for a number of set of outcomes, looking at cognitive ability again, but looking at a range of other skills and anthropometrics and various forms of behavior and social emotional skills. Using the Chilean Encuesta Longitudinal de la Primera Infancia, using the data from 2010, this is a representative sample based on birth records of almost 14,000 children in this age range. There's also the age range 0 to 8 months, and includes a number of measures of child development in addition to family background kind of measures. So for cognitive skills, we're looking at different measures where these measures differ in part because of the different age range of the children, as indicated on this table. The Peabody picture vocabulary test is the one that was used for the comparison across countries that I showed before. For anthropometric measures, we're looking at z-scores, which, as you probably know, is the number of standard deviations below the reference, below or above the reference median, with the references used, often international references. So we're looking at for length for age, which is thought to be a good measure of long-run nutritional status, weight for length, BMI, the body mass index, and head circumference. For motor skills, we have indicators for different age ranges again, both from the Battelle battery and psychomotor development. Some examples are given in the right-hand column of what these scores are measure, or what observations are used to get to these scores. Behavioral skills, we have a child behavior checklist, and we create an index from that having to do with being able to pay attention, impatience, those sorts of characteristics. Social emotional skills, we again have multiple indicators, primarily from a series of tests that have been used internationally. So most of these tests, most of these measures, with the exception, I guess, of TIPSY, have been used broadly internationally, and TIPSY's been used extensively in Chile. So first, just looking at correlation matrices among the various indicators, and these are presented by different ranges of months for ages. This is for 9 to 18 months. And the basic point here is, and this is the basic point for all these correlation matrices, is these correlations are far from one generally. I mean, some of them are pretty high, where you would think inherently by measurement problems they will be high, such as the BMI for weight for length versus, the z-score for weight for length versus the z-score for BMI. But there's generally, these indicators are often correlated, but far from perfectly correlated. So if one's interested in the general process of child development, and if it's the case that something besides cognitive skills are important, then it's probably important to understand more than just the cognitive skills. So now I'm going to do something that they tell you never to do when you're giving a presentation, and that is I'm going to give you 3 million slides very quickly. They're organized by group, first starting in the patterns for cognitive skills. Generally, I will include these patterns with regard to income, but also with regard to some other variables, particularly related to maternal education and maternal knowledge. This is the TVIP. This is the one that was in the comparison across countries, the lowest and the highest quintile. Probably no surprise there, a significant gap that increases somewhat with age. This is, again, the TVIP, this time with 3 categories of maternal education. The pattern's probably what you would expect. More schooled women have children who do better on this, possibly some divergence over time. This is the Wechsler measure of maternal cognitive abilities, with the very good being the green, intermediate being the red, poor being the blue. Again, getting this same pattern with some divergence as the children age. This is now going to the Battelle cognitive measure. This is for a different age range. These are relatively young children. Again, some difference by income quintile, by maternal schooling. This is the Battelle communication, a smaller difference. Likewise, with regard to maternal schooling, this is the TEPSI language score. You know, the same pattern, I would say, is there. So, you know, generally with the income, with the cognitive ability, there seems to be, in most cases, a systematic pattern where the highest income quintile has significantly higher scores than lower, where maternal education or maternal knowledge plays a role. Looking then at anthropometrics and motor skills. This is the Z-score, length for height. You know, it's nutritional status, long-run nutritional status. One gets this pattern. Much less so with maternal education than with the cognitive skills. This is for BMI. Here, the pattern is, it's very mushy if there's any pattern, but it might be the case that the values for BMI are higher for the less educated mothers, which reflects perhaps the differential spread of obesity in Chilean society. This is looking at BMI again with the income quintiles, mother's education. Weight for length is related to BMI, but the patterns look a little different, a little bit more emphasis on the higher quintile. This is head circumference, again a little higher for the higher income quintile. This is coordination as measured by the TEPI score, same sort of pattern. This is motor skill, seems not to be significantly different by income quintile. This is a motor skill at an earlier age in life. So, you know, there's some of the same patterns in the anthropometrics, but they're probably, you know, less pronounced, I would say, in summary. Turning now to behavior and social emotional skills. For the Battelle indicator of adaptability early in life, it appears really no significant difference by income quintile or by maternal schooling. For the social skills, however, there does appear to be a significant difference by income quintile, and again by maternal schooling, with the children are the better off doing better. This is an alternative measure of social emotional skills. But I should point out here, and point out for the next few slides, that this is a negative indicator. This is basically social emotional behavioral problems rather than skills. So the fact that the lowest quintile is above the highest quintile is consistent with what your priors would be. And for all the indicators that are negative, it says negative on the slide in case I forget to remind you of that. For maternal education, similar kind of pattern, worse behavior with the less schooled mothers. This is an alternative behavioral index for a wider and older age range. Here, again, there appears to be significant differentials that persist at least over the age range considered. Likewise with maternal schooling. Another negative indicator, the ages and stages indicator, pretty strong difference over the early months of life by quintile. Pretty strong difference between mothers having a lot of schooling and have intermediate or limited schooling in regard to maternal schooling. So, you know, these graphical findings, just describing the data, suggest that, you know, certainly for cognitive skills, even at very young ages, there appear to be some associations that are pretty strong by income quintile and by education and maternal achievement scores. There's some evidence of some possibility of divergence after about age 3 in some of these graphs. And this divergence really reflects little change in the lowest quintile while the top quintile tends to increase, and that's reflected most sharply perhaps in these Peabody scores. For the anthropometric measures, the patterns by income are less clear, though there are some differences in regard to coordination and possibly motor skills. But there's pronounced differences in the behavioral and social-emotional indices at young ages and some possibilities of divergence. So another way we're going to just summarize these patterns to wrap up is by looking at regressions for some of these outcomes. Each regression will control for the age dummies. The first regression will also control for the income quintiles. The second regression will control, in addition, for a number of other characteristics, including maternal, paternal schooling, maternal test results, birth weight, some other characteristics like that. So this is for the TVIP. Up in the upper right-hand corner are the results if you only have the income quintiles in. And as is indicated, suggested by the earlier results, there are strong, significant patterns that you get higher values as you get to higher income quintiles. On the left, it still includes the income quintiles, and the gold and yellow bars down low in the graph indicate still significant associations of the income bars, but much less large once you control, particularly for maternal skills. Father's education, father's schooling is a pretty strong association, and some other associations associated with maternal ages. So this may be suggestive of the channels through which income is having effect, or at least the associations underlying any effect that income may have. I slipped into saying effect. That was a mistake. Go back, replace effect with associations, because that's certainly all I'm talking about. The Battelle communication, a similar pattern when you just have the income variables in, and in some ways a fairly similar pattern when you have all these other characteristics included. In this case, particularly maternal scores on vocabulary test and paternal schooling have strong, significant activities, strong, significant associations, and strong enough that it wipes out any association with income once you control for them. Also note at the top, and remember the Battelle is for very young children, that being enrolled in daycare center is negatively associated for these very young children with this kind of indicator. For the Battelle cognitive, roughly the same pattern when only income is included, roughly the same pattern when these other variables are included. For the TEPSI language, the same kind of pattern when only income is included. Similar patterns in many respects when maternal and paternal variables are included. In this case, the income variables still have a significant association, even controlling for maternal and paternal education. And note that being enrolled in day care for children of this age range, this is an older age range, is positively associated with performance on the TEPSI. Length for age, long-run nutritional status, the Z-score, the just income patterns, again, are very similar. Here, there's somewhat the same kind of lessening and associated with income as you include more information about mother's schooling and particularly mother's age. But very importantly, low birth weight has a very strong negative association at the bottom of the graph. The score for BMI, it appears as in the graphs. The BMI is bad in the sense of probably pertaining to greater probability of obesity and is less for higher income quintiles. It's also, when you put in the other variables, is reduced significantly by father's schooling and by low birth weight. Z-scored weight for length, basically a fairly similar pattern given the time, and likewise with Z-score head circumference. This is the TEPSI coordination measure. And again, it's in some sense the same kind of pattern. Pretty strong pattern with income alone. Those associations basically disappear with maternal and paternal schooling. In this case, for this age range, enrollment in daycare is positively associated with it. Motor skills, same thing. Personal social